Section 5.4a, sum and difference formulas. Find the sine, cosine, and tangent of x equals 75 degrees. Up until now, everything that we have done has been either a multiple of our 0, 30, 45, 60, or 90. In this case now, this is where we can use the sum and difference identities. We do not know how to find the exact value of 75 degrees, okay? We know our 30, 60, 90 triangles, we know our 45, 45, 90 triangles, and everything we've drawn as far as reference triangles has been a multiple of one of those two triangles. So in this case, what we need to do is we need to break 75 down into two angles that we do know how to find exact values for. What two angles add up to 75 degrees? 30 plus 45. So we're going to use our sum identity for sine here to begin. Sine of 45, sine of 75 is the sine of 45 plus 30. Apply your identity now. Sine A, cosine B, sine 45, cosine 30, plus sine B, cosine A, sine of 30, cosine of 45. Now we just need to evaluate each of those. So draw your reference triangles. 45-degree angle, 1, 1, root 2. 30-degree angle, 1, root 3, and 2. So what is the sine of 45 degrees equal to? Opposite over hypotenuse, 1 over root 2. What's the cosine of 30 degrees? Adjacent over hypotenuse, root 3 over 2. Sine of 30, opposite over hypotenuse, 1/2. And cosine of 45, adjacent over hypotenuse, 1 over root 2. Simplify. Multiply fractions, we multiply straight across. We get root 3 over 2 root 2 plus 1 over 2 root 2. I already have a common denominator, so that's the same thing as root 3 plus 1 over 2 root 2. Finally, rationalize. We rationalize by multiplying by the radical over itself. When we do that, up top, we get root 6 plus root 2 all over 4. There's the exact value of the sine of 75 degrees. Cosine of 75, set up the same way. Cosine of A plus B, 45 plus 30. Cosine A, cosine B, minus sine A, sine B. Cosine of 45, if we go back here and look, cosine adjacent over hypotenuse, 1 over root 2. Cosine of 30, adjacent over hypotenuse, root 3 over 2. Sine of 45, 1 over root 2. Sine of 30 is 1/2. Simplify. Root 3 over 2 root 2 minus 1 over 2 root 2. Add the fractions and rationalize. Root 6 minus root 2 all over 4. There's the cosine of 75. Finally, the tangent of 75, set up the same way. Tangent of A plus B, or tangent of 45 plus 30 is equal to, apply your sum identity, tangent of 45 plus tangent of 30 over 1 minus tangent of 45 times the tangent of 30. Tangent of 45 is 1. Go back to your reference triangle on the previous 2 slides if you need to. But tangent of 45 is 1. Tangent of 30 is 1 over root 3. In the bottom, we have 1 minus 1 times 1 over root 3. From here, begin simplifying. We're going to end up with a complex fraction here. If I work over here, we end up with 1 plus 1 over root 3 over 1 minus 1 over root 3. There's our complex fraction. Get a common denominator and begin simplifying. Remember, for a complex fraction, 3 steps. Simplify the top, simplify the bottom, multiply up by the reciprocal. Up top, our common denominator is root 3. We end up with root 3 plus 1. In the bottom, our common denominator is root 3. We end up with root 3 minus 1. Now when I multiply up here by the reciprocal, our root 3's cancel. I'm left with root 3 plus 1 over root 3 minus 1. Need to rationalize. We rationalize this time by multiplying by the conjugate. Up top, it's just going to become a FOIL situation. We get 3 plus 2 root 3 plus 1. Bottom, conjugate pairs, first thing squared minus the second thing squared. Continue simplifying. Up top, 4 plus 2 root 3 all over 2. And finally, we can take a 2 out of everything, and we're left with 2 plus root 3. There's the exact solution for the tangent of 75 degrees. Cosine of pi over 12. Pi over 12 is the same thing as 15 degrees. So we need to figure out what 2 angles can we combine to equal 15 degrees. Again, that's going to be 45 and 30. That's the same as 45 minus 30. So we're only finding the cosine here. Cosine of 45 minus 30. Apply now your difference identity for cosine. Since this was given in radians, let's continue in radians here. So that's the cosine of pi over 4 minus pi over 6. Apply your difference identity, cosine A, cosine B, plus sine A, sine B. Cosine of pi over 4, reference triangles I'm not going to draw again. Those were on the first sheet if you need to refer back to them. Cosine of pi over 4 is 1 over root 2. Cosine of pi over 6 is root 3 over 2. Sine of pi over 4, 1 over root 2. Sine of pi over 6, 1/2. Multiply the fractions. Add them together. Root 3 plus 1 over 2 root 2. And rationalize. We end up with root 6 plus root 2 all over 4. Last one. Sine of 42, cosine of 12, minus cosine of 42, sine of 12. You need to recognize this pattern. Recognize this pattern as being one of your sum or difference identities. This would be the same as sine A cosine B minus cosine A sine B. What is that an identity for? Well, A in this case is 42 degrees. B in this case is 12 degrees. So that's 42 minus 12. That's an identity for the sine of A minus B. What's A in this case? Well, A was 42. b is 12. So this is the same thing as just finding the sine of 30 degrees. (30 degrees), 1, root 3, and 2. What's the sine of that equal to? 1/2.